Hello friends, welcome to LS Academy for Technical Education. In today's video, we will discuss about the Unit 3, Unit 4 and Unit 5 of data compression multiple choice question which is based on the AKTU Lucknow syllabus. This is the part 2. Part 1 we have already discussed about Unit 1 and Unit 2. So let's start from question number 1. Predictive coding is used for A. Lossless image compression, B. Lossy image compression, C both A and B, and D none of these, and the correct option is A lossless image compression. Predictive coding means there will be transmission of difference between current pixel and previous pixel. A true, B false, and the correct option is A true. MED, GED, GAP are example of A transform coding, B dictionary coding, C entropy coding, or D predictive coding, and the correct option is D predictive coding. PPM is A. Prediction by pattern matching, B. Partial pattern matching, C. Prediction by partial matching, or D. None of the above. And the correct option is PPM is prediction by partial matching. So C is the correct option. Borrow, Wheeler transform rearranges a character string into runs of different characters. True or false? And the correct option is B. False. Gzip, bzip2 and zip commands are A. Unix command, B. Windows command, C. Linux command, or D. both A and C यानी कि Unix or Linux command, and the correct option is D. both A and C. Move to front or MFT algorithm is a transformation algorithm which does not compress data. A. True, B. False, and the correct option is A. True. JPEG LS is A lossy JPG or B lossless JPG, and the correct option is B. JPEG LS is based on dash algorithm. A high complexity, B low complexity, C medium complexity, or D none of these, and the correct option is B low complexity. JPEG LS is an image compression standard ISO IEC 14495-1 ITU-TREC.T.87 designed to provide effective lossless and near lossless compression. A true, B false, and the correct option is A true. JPEG LS is a simple and efficient algorithm that mainly consists of two stages, modeling and encoding. A true, B false, and the correct option is A true. CALIC is A. Context-based adapted lossless image codec, B. Calculative image compression, C. Context-based adaptive lossy image codec, or D. None of these, and the correct option is A. Diagram coding is A. Lossy data compression, B. Lossless data compression, C. Both A and B, D. None of the above, and the correct option is B. Lossless data compression. Prediction by partial matching (PPM) is an adaptive statistical data compression technique based on the context modeling and prediction. A. True, B. False, and the correct option is A. True. V.42 BIS is a standard for data compression modems. A. True, B. False, and the correct option is A. True. B.42 BIS used a variant of A. LZ77 compression method, B. LZ78 compression method, C. LZW compression method, or D. None of the above, and the correct option is C. LZW compression method. LZ77 and LZ78 are the two dash data compression algorithms, A. Lossless, B. Lossy, and the correct option is A. The LZ77 algorithm works on dash data, whereas LZ78 algorithm attempts work on dash data. A. Future, past, B. Past, future, C. Present, future, D. Past, present. And the correct option is B. Past, future. LZ78 has dash compression but very dash decompression than LZ77. A. Fast, slow, B. Slow, fast, C. None of these. And the correct option is B. Compression packages which uses an LZ77 based algorithm followed by a variable length coder. A. PKZip, B. Zip, C. PNG, D. None of all of the above. And the correct option is D. All of the above. Application of LZW. A. GIF, B. ZIP, C. PNG, or D. All of the above. And the correct option is A. GIF. JBIG stands for A. Joint Bi-Level Image Export Group, B. Joint Bi-Level Image Export Group, C. Joint Binary Image Experts Group, D. None of the above. And the correct option is A. JBEIG2 compression is A. Lossless compression, B. Lossy compression. And the correct option is B. Lossy compression. The main features of JBIG are A. Lossless compression of 1 bit per pixel image data, B. Ability to encode individual bit lanes of multiple bit pixels, C. Progressive or sequential encoding of image data, D. All of the above. And the correct option is D. All of the above. The GIF image can be transferred over the network in dash A. Interlaced image, B. Interlaced mode, C. Interchange mode, D. Interchange image. And the correct option is B. Interlaced mode. Prediction by partial matching of PPM is a method to predict the next symbol depending on a previous. This method is else called prediction by dash model. A. Probability, B. Physical, C. Markov, D. None of the above. And the correct option is C. Markov. Where does the hidden Markov model is used? A. Understanding of real world, B. Speech recognition, C. Both, D. None of the above. And the correct option is B. Speech recognition. The Burrows-Wheeler transform of BWT, also called block sorting compression, is used to compress A. Floating numbers, B. Strings, C. Real numbers, D. All of the above. And the correct option is B. Adaptive dictionary: A. Holding string previously found in the input stream, B. Sometimes allowing the addition of strings but no deletions, C. Allowing for addition and deletion of strings as new input symbols are being read, D. Both A and B, E. Both A and C. And the correct option is E. Both A and C. In Landé-Bozzio-Gray algorithm, at each iteration, each vector is split into A. 2 new vectors, B. 3 new vectors, C. 4 new vectors, D. 8 new vectors. And the correct option is A. 2 new vectors. The process of converting the analog samples into discrete form is called A. Modulation, B. Multiplexing, C. Quantization, D. Sampling. And the correct option is C. Quantization. Quantization is a dash process. A. Few to few mapping, B. Few to many mapping, C. Many to few mapping, D. Many to many mapping. And the correct option is C. Many to few mapping. Quantization is a dash process. A. Nonlinear, B. Reversible, C. Nonlinear reversible, D. None of the mentioned. And the correct option is A. Nonlinear. What are the types of quantization error? A. Granular error, B. Slope overload error, C. Both A and B, D. None of the above. And the correct option is C. One bit quantizer is A. Hard limiter, B. Two level comparator, C. Hard limiter and two level comparator, D. None of the mentioned. And the correct option is C. Uniform quantization provides better quantization for A. Weak signal, B. Strong signal, C. Weak and strong signal, D. None of the mentioned. And the correct option is B. Non-uniform quantization provides better quantization for A. Weak signal, B. Coarse signal, C. Weak and coarse signals, D. None of the mentioned. And the correct option is A. In non-uniform quantization, the quantization noise is dash to signal size. A. Inversely proportional, B. Directly proportional, C. Equal, D. Double. And the correct option is B. The output SNR can be made independent of input signal level by using A. Uniform quantizer, B. Non-uniform quantizer, C. Uniform and non-uniform quantizer, D. None of the mentioned. And the correct option is B. Non-uniform quantizer. What are the types of quantizer? A. Mid-range quantizer, B. Mid-trade quantizer, C. Both A and B, D. None of the above. And the correct option is C. Both A and B. Which of the following characterize a quantizer? A. Quantization results in a non-reversible loss of information. B. A quantizer always produces uncorrelated output samples. C. The output of a quantizer has the same entropy rate as the input. D. None of the above. And the correct option is A. Which type of quantization is most preferable for audio signals for a human ear? A. Uniform quantization, B. Non-uniform quantization, C. Uniform and non-uniform quantization, and D. None of the mentioned. And the correct option is B. The output signal of a scalar quantizer has property A. The output is a discrete signal with a finite symbol alphabet. B. The output is a discrete signal with a countable symbols alphabet, but not necessarily a finite symbol alphabet. C. The output signal may be discrete or continuous. D. None of the above. And the correct option is B. Transform coding vector quantizations are examples for A. Pixel, B. Compression, C. Transmission, D. Lossy compression. And the correct option is D. Lossy compression. Which of the following statement is correct for comparing a scalar quantization and vector quantization? A. Vector quantization improves the performance only for sources within memory. For IID sources, the best scalar quantizer has the same efficiency as the best vector quantizer. B. Vector quantization does not improve the rate distortion performance relative to scalar quantization, but it has a lower complexity. See, by vector quantization, we can always improve the rate distortion performance relative to the best scalar quantizer. D. All of the above. And the correct option is C. The process of representing a dash possibly infinite set of values with a much dash set is called quantization. A. Large comma small, smaller. B. Smaller comma large. C. None of these. And the correct option is A. Large comma smaller. The set of inputs and outputs of a quantizer can be A. Only scalar, B. Only vector, C. Scalar or vector, D. None of these. And the correct option is C. Scalar or vector. If a 0 is assigned a decision level, then what is the type of quantizer? A. Mid-range quantizer, B. Mid-range quantizer, C. Mid-range quantizer, D. None of the above. And the correct option is B. Which of the following are correct for uniform quantizer? A. The simplest type of quantizer is the uniform quantizer. B. All intervals are the same size in the uniform quantizer except possibly for the two output intervals. C. The decision boundaries are spaced evenly. D. All of the above. And the correct option is D. All of the above. If a 0 is assigned a quantization level, then what is the type of quantizer? A. Mid-range quantizer, B. Mid-range quantizer, C. Mid-range quantizer, D. None of the above. And the correct option is A. The main approaches to adapting the quantizer parameters: A. An offline or forward adaptive approach, B. An online or backward adaptive approach, C. Both, D. None of the above. And the correct option is C. Both. Non-uniform quantizer dash distortion: A. Decreases, B. Increases, C. Does not change, D. None of the above. And the correct option is A. Decrease. Dash equal to DCT coefficient minus D quantized value. And the correct options are A. Quantization process, B. Quantization error, C. Quantization percentage, D. Quality process. The correct option is B. Quantization error. Uniform quantizer is also called as A. Low-rise quantizer, B. High-rise quantizer, C. Mid-rise quantizer, D. None of the above. And the correct option is C. Mid-rise quantizer. In uniform quantization process, A. The step size remains same, B. Step size varies according to the value of input signal, C. The quantizer had linear characteristic, D. Both A and C are correct. And the correct option is D. What are the process techniques used in video coding? A. Partition of frames into macro blocks, B. Forms of vector quantization, C. Both A and B, D. None of these. And the correct option is C. The Linde-Vizo-Gregg algorithm is a dash quantization algorithm to drive a good code work. A. Scalar, B. Vector, C. Both, D. None of the above. And the correct option is B. Vector. Vector quantization is used in A. Video coding, B. Audio coding, C. Speech coding, D. All of the above. And the correct option is C. Speech coding. Vector quantization is used for A. Lossy data compression, B. Lossy data correction, C. Pattern recognition, D. All of the above. And the correct option is D. Which of the following are correct for advantages of vector quantization over scalar quantization? A. Vector quantization can lower the average distortion with the number of reconstruction levels held constant. B. Vector quantization can reduce the number of reconstruction levels when distortion is held constant. C. Vector quantization is also more effective than scalar quantization when the source output values are not correlated. D. All of the above. And the correct option is D. Let n represent the dimensions of a vector quantizer. What statement about the performance of the best vector quantizer with dimension n is correct? A. For n approaching infinity, the quantizer performs asymptotically, approaches the rate distortion function theoretically limit. B, by doubling the dimension n, the bit rate for the same distortion is halved. C, the vector quantizer performance is independent of n. D, all of the above, and the correct option is A. Vector quantization is rarely used in practical applications. Why? A. The coding efficiency is same as for scalar quantization. B. The computational complexity, in particular for the encoding, is much higher than in scalar quantization and in large codebook needs to be stored. C. It requires block Huffman coding of quantization indexes, which is very complex. D. All of the above, and the correct option is B. What characterizes a vector quantizer? A. Multiple input symbols are represented by one quantization index. B. Multiple quantization indexes are represented by one codeword. C. Each input symbol is represented by a fixed length codeword, and the correct option is A. If the dynamic range of the signal is smaller than the range of the quantizer, the samples that exceed the quantizer are clipped, resulting in large quantization error. A. True, B. False, and the correct option is B. False. Characteristics of a vector quantizer. A. Multiple quantization indexes are represented by one code word. B. Each input symbol is represented by a fixed length code word. C. Multiple input symbols are represented by one quantization index. D. All of the above, and the correct option is C. In dictionary techniques for data compaction, which approaches of building dictionaries used for the prior knowledge of probability of the frequently occurring patterns? A. Adaptive dictionary. B. Static dictionary. C. Both. D. None of the above. And the correct option is B. Static dictionary. Which is the fixed range of quantization error EQN? A. Minus dash by 6 less than equal n less than equal to delta slash 6, or B. Minus delta by 4 less than equation delta by 4. C. Minus delta by 2 plus delta by 2. D. Minus delta by 16 2 plus delta by 16, and the correct option is C. Minus delta by 2 plus delta by 2. In the mathematical model for the quantization error equation n, to carry out the analysis, what are the assumptions made about the statistical properties of equation n? First, the error eqn is uniformly distributed over the range minus delta by 2 less than plus delta by 2. Second, the error sequence is a stationary wide noise sequence. In other words, the error eqm and the error eqn for m is not equal to n are uncorrelated. Third, the error sequence eqn is uncorrelated with the signal sequence xn. Fourth, the signal sequence xn is zero, mean and stationary, and the options are A. First, second, third, B. First, second, third, fourth, C. First and third, and D. Second, third, and fourth. And the correct option is B. First, second, third, fourth. All are assumptions that are made. Static dictionary. A. Permanent. B. Sometimes allowing the addition of strings but no deletion. C. Allowing for addition and deletion of strings as new input symbols are being used. D. Both A and B. And the correct option is D. Both A and B. Which is a quantization process? A. Rounding. B. Truncation. C. Rounding and truncation. D. None of the mentioned. And the correct option is C. Rounding and truncation. Dash value equal to round value into threshold. A. Quantize. B. Dequantize. C. Compressed. D. Uncompressed. And the correct option is B. Dequantized. What is a Lloyd quantizer? A Lloyd quantizer is a scalar quantizer that yields the minimum distortion for a given source and a given number of the quantization intervals. B. The output of a Lloyd quantizer is a discrete signal with the uniform PMF. C. For a given source, the Lloyd quantizer is the best possible scalar quantizer in rate distortion sense. That means there does not exist any other scalar quantizer that yields a smaller distortion at the same rate, and the correct option is A. A Lloyd quantizer can be considered as optimal quantizer for fixed length coding of the quantization indices. Can we improve a Lloyd quantizer by using variable length codes? A. No, variable length coding does not improve the quantizer performance since all quantization indices have the same probability. B. No, variable length coding does not Improve the quantizer performance. In the quantizer, output is uncorrelated. C. Yes, in general, the quantizer performance can be improved by variable length coding, as there are some exceptions for the special purpose.